All right, 2.4 part 1, we're going to do operations with scientific notation. Today we are concentrating on just adding and subtracting with scientific notation. So only adding and subtracting. So key terms, we don't have any because we've been talking about scientific notation and we know how to add and subtract. All right, so when we add or subtract, it's the same for both. The only way to do it is to first transfer so that all of the exponents are matching. I cannot add these because they are not in the same exponents. Basically what we're doing is transferring their exponents so that they have matching exponents, same bases. Then we can add them up because it'll give me all the same bases. So for this first one, we can either change both 6's to make a 5, or we can change the 5 to be a 6. I'm going to go with change the 5 to be a 6, because then it's only one thing I have to change instead of two. So the way we change a 5 to become a 6 is we're just going to add 1 to the exponent. Now, it's growing, the number is getting bigger, and so when we do that, we're going to move the decimal. Right, when we have an exponent, when we're changing from standard to scientific, exponents move to the left. And so, and I'll show you what it does, but I'll show you that they're equal. So what we're going to do is, since I added 1 here, I'm going to actually move my decimal over 1 time to the left as well. Okay, so let me show you. 2.25 times 10 to the 5th. If I transfer this to standard, 1, 2, 3, 4, 5, becomes this number. Now, if I take my new number, 10 to the 6, and transfer it to standard, 1, 2, 3, 4, 5, 6. And you'll see that it's actually the exact same number. So we just need to remember that when we change standard to scientific, if we need to get them bigger, we move to the left, and if they need to get smaller, we move to the right. So if we had moved the 6's, we would have moved our decimals to the right to match the 5, but I didn't because I only wanted to change 1. So now what we have is all matching bases. So this number is now this number. Now that they're all matching bases, we can actually just add the digits up. So I'm going to take 4.2, add it to my 225, and then add it to my 2.8. I only can do this now that my exponents match. So we get 5, 2, 8, 9, 10, 11, 12, 4, 5, 6, 7, 8, right? 4, 5, 6, 7, 8. So we rewrite our number that we just got, 8.225, and we just go times 10 to the 6. We keep our base and we keep our exponent. We don't have to change it back. We don't have to do anything after, as long as our number is still between 1 and 10 in scientific notation, which it is in this case. So if we look at our next example, we have all matching exponents. So that's really nice because we don't have to move anything. So look, 10 to the second, 10 to the second, 10 to the second. So we just are going to take our 1 and 2500ths, add it to our half, and add it to our 3 and 2500ths. Let me put my 0 here. And then we're going to add. So we get 10, 5, 6, 7, 8, 9, 10, 3, 4, 5. And so I get 5 times 10 to the second. And I'm done. So that was nice because we didn't have to change any of my exponents. All right, so this is the same page, just down below. So this says the table below shows the population of the 3 largest countries in North America in 2011. Find the total population of these countries. So here they are in scientific notation. None of them match. Well, actually 2 of them match. This time I'm going to make the big exponents become the small exponents. Okay, just show you that it, it doesn't really matter. So I'm going to go minus 1, minus 1. Now they're going to become times 10 to the 7th. But because I'm making the exponent smaller, we're actually going to move it to the right this time. And I know those are not in scientific notation, but it's okay. We don't care about it until the very end. So now that I have them all in the same base, I can find the total. If I want to find the total, I just add them together. So I'm going to go 31 plus 3.38 plus 11. We get 8, 3, 3, 4, 5, 3, 4, bring my decimal down. So we get 45 and 3800ths times 10 to the 7. But this right now is not in true scientific notation. So we have to then switch it so it's in true scientific notation. We're going to move it 1 time to the left to get it between 1 and 10, so 4.538. And because we moved to the left and we got bigger, right? We're making that's a bigger number. We're going to add 1 and get it to the 8th. And now look, it's back to the 8th anyways, which is what we could have changed to 7. So the answer is still the same no matter which way you move it. Okay? I just want to show you that you could change more than 1. Okay? The biggest thing I want you to get out of this is you have to change the exponents to match. And if we're making the exponent bigger, we're going to move to the left. And if we're making the exponent smaller, we're going to move to the right. Just like we did when we changed it from standard to scientific. When we moved to the left, our number got bigger. Our exponent kept growing. Move once, twice, 3 times, so on, and it grows. When we move to the right, technically the exponent gets smaller. -1, -2, -3, -4. Okay? Now with subtraction, it's exactly the same. Except you're going to subtract your numbers. So this is the only thing you have to be careful with, is that you have to subtract from left to right in this case. Okay? Now they don't match. So I'm going to change this one. I'm going to -1 and move it to, not -1, +1. Here we go, +1 and move it to the left. So I'm going to first take 8 and 5/10 and subtract 5 and 3/10. They match, so I can just subtract. So I'm going to get 2, 3, and that's times 10 to the 3rd. Then I'm going to subtract my 10th times 10 to the 3rd. Okay, because now I'm going to keep moving. So I'm going to take 3 and 2/10 and subtract a 10th. And I get 3 and 1/10, and now my new exponent is to the 3rd. So I'm going to go 3.1 times 10 to the 3rd. And that's our final answer. But we got to subtract from left to right. Okay, we have to subtract from left to right. Okay, so now in this case, we actually have all 3 different exponents, which means we're going to have to move 2 of them or all 3 of them so that they match. Okay? I personally always like to move my exponents to the biggest number. So in this one, 4, I'm just going to add 1, so I'm going to move it once. But in this one, from 2 to 5, I'm actually going to add 3, which means I need to move 1, 2, 3. So here's my new math problem. 6 and 2/10 times 10 to the 5th minus 2600ths times 10 to the 5th minus tens, hundreds, thousands, 10 thousandths, 19 10,000ths times 10 to the 5th. Now that they all match, I can start subtracting. So I'm going to go 6 and 2/10 minus 2600ths. So I have to borrow 4, borrow 11, 10, 9. Okay, so we get 5 and 9400ths. Now that I have that, I'm going to subtract this crazy big decimal. You have to line your zeros up and your decimals up, so add these zeros. Now this is where people make mistakes. They just say 9. We have to borrow from all the way over here. It's called a double borrow, so that we can actually subtract. We can't take away 9 from 10, from 0, so we have to double borrow. So this becomes 1. Now we have enough here too. We're going to get 8. Then we get 3. Then we get 9. Then we get 5. So we get 5 and 9,381 10,000ths times 10 to the 5th. The trickiest thing is this double borrowing and this borrowing. When we subtract, that's the mistake most people make, is they don't borrow. We are subtracting. All right. So here we have 3 new countries, China, France, and Australia, and we want to know how many more people live in France than in Australia. So anytime you ask for how much more, like how much more money do I have than you? How much older am I than you, right? What's the difference in our ages? What's the difference in our money? What's the difference in their populations? That's always subtraction. So how many more do you have than me is always subtraction. So we only care about France and Australia. And yay, they actually match. So we're going to take our 6 and 4800ths, and we're just going to subtract our 2 and 1500ths. So 3, 3, 4, and because they matched, we don't have to move anything. And there's our answer. All right, so things to remember. Must have matching exponents. Okay, exponents get bigger. Move to the left. Exponents get smaller. Oh, that should say bigger, bigger. Oops. Move to the right. All right, so you only have one independent practice. It says, what's the total amount of paper, glass, and plastic waste generated? Okay? So this is where you're going to have to pay attention. It's asking about the paper, the glass, and the plastics waste generated, and it's asking for the total. So see if you can decipher what information you need. All right, until next time.